Hello everybody, this is our video number 1 on the topic the 3-dimension geometry. But it is our class number 2. In our first online class, we already discussed what is the direction cosine, what is the direction ratio and the various form of the straight line. That means the various equations, and after that how to find out the shortest distance between the two straight lines and the two parallel lines. In this video, we will start a new topic of the 3-dimension geometry, that is the plane. And as per your revised syllabus, the equation of a plane in form of the vector form and the Cartesian form, and the distance between a point to a plane is included in your syllabus, but the angle between a line and plane is excluded from your syllabus. So today we will discuss each and every form of the equation of a plane. The first one, consider the equation of the plane in a normal form, and this time it is the r vector dot n vectors is equal to d. This is the vector form of this normal form, and remember this n is a vector which is normal to the particular plane, and this d is the distance between the origin to this particular plane. And if you consider that this one, ax plus by plus cz is equal to d, and this time this abc is nothing but the direction ratio of this particular normal, and d is the distance between the origin to this plane. Second one, the equation of a plane which is perpendicular to a vectors and the passing through a point. This time the equation, the r vectors minus a vectors. What is the a? A is the position vector of this particular point which is the passing through the particular plane, and n is this perpendicular vectors. And this is the Cartesian form of this equation of this plane: a into x minus x1 plus b into y minus y1 and c into z minus z1 equal to 0. And this time is a, b, c is nothing but the direction ratio of this normal perpendicular vectors, and this x1, y1 and z1 this particular point passing through the three non-collinear point, and this time the r vector minus a vector into the b vector minus a vector cross product between the c vector minus a vectors is equal to 0. And this time this a, b and c, this a, b and c is nothing but the position vectors of these three given points, and this is this determinant, the x minus x1, y minus y1 and z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1 and z3 minus z1 is equal to 0. This is the form, the Cartesian form of this given equation when the 3 points is given, and this 3 point in condition is the plane is passing through the 3 non-collinear points. So this is the Cartesian form. And consider the question number 5, that is the x by a plus y by b and z by c is equal to 1. That is the intercept form of a particular plane. And 6, the passing through the line of intersections of the two given plane. So this is the equation of this particular plane which is passing through the line of the intersections of the two given point. This time the r vector dot n vector plus lambda into n2 vector is equal to d1 plus lambda d2, and it is a Cartesian form. a1x plus b1y plus c1z plus minus d1, and this is nothing but this one, the Cartesian form of the equation of the plane in normal form. So remember all those equations, and with the help of all those equations we will solve the sum problem in the exercise 11.3. So exercise 11.3 from your NCERT. So consider question number 1b. Question number 1b. What is the question? The question is, in each of the following cases, determine the direction cosine of the normal to the plane and the distance from the origin. So the given equation is x plus y plus z is equal to 1, and we are already familiar with this equation. Ax plus by plus cz is equal to b, and this is the equation of a plane in a normal form. It is a Cartesian form, and this time this a, b, c is nothing but the direction ratio of this normal of a plane. And if you compare this one, this time the a is 1, b is 1, and c is also 1, and from this we calculate 1 square, 1 square, 1 square. That means we get root 3. And suppose we consider that this one is our equation 1, and after getting this value, divide the both sides of the equation 1 with this. And after the divisions, and this time, after getting this step, this 1 by 3, 1 by 3 and 1 by 3 is nothing but the direction cosine of this normal. Okay? So this 1 by 3 is the direction cosine of the normal to the plane, and this time this d, this is the value for the d. That means this is the distance. This is the distance from the origin to the plane. So this is the answer. And with the help of this concept, we can easily solve question number 1, A, B. So all the question of question number 1, A, B, C and the D are the same value. Okay. So next one. The next one. Find the vector equation of a plane. Question number 2. Find the vector equation of a plane which is a distance of 7 units from the origin and the normal to the vector. That means the d is given, this is 7, and the normal to the vectors is 3I cap plus 5j cap minus 6k cap, and it is nothing but the n vectors. Okay, so this is the normal to this vectors, and what is the value? That means the r vector into n vectors is equal to d, and this time this n is a unit vectors of this normal this time. So this n cap, and this time it is denoted by n cap, and this n cap is nothing but n vector mod of n vector. So what is the value? The 3I cap plus 5j cap minus 6k cap by root over 9 plus 25 plus 36, and from this we can easily get the right. This is 9 plus 26, that means it is 34, and 34 under it, that means root 7, and from this we can write the r vector dot the 3I cap plus 5j cap minus 6k cap by root 70 is equal to 7. So this is the particular equations. The next one, question number 3. Question number 3A. The r vector dot I cap plus j cap minus k cap is equal to 2. So find the Cartesian equation of this following plane. So how to find out the equivalent, the Cartesian form of this particular equation of a plane? So first of all, we consider a point P and the coordinates of this plus x, comma, y, comma, z. Okay? And the position vector of this P is xi cap plus yj cap plus zk cap. This is the position vectors of this P points, and if you put this value in place of this r, that means xi cap plus yj cap plus zk cap is dot I cap plus j cap minus k cap is equal to 2. And after performing the dot product, we already know that this one, the x plus y minus z is equal to 2. This is the equivalent Cartesian form of this particular equation of the plane. And with the help of this concept, we can easily solve all the questions of question number 3. That means the 3 of A, B and C the same time. Okay? And the question number 4. A. In the following cases, find the coordinates of the foot of the perpendicular drawn from the origin. So, given equation is the 2x plus 3y plus 4z minus 12 is equal to 0. Okay? And from this we can write the 2x plus 3y plus 4z is equal to 12. And it is nothing but the x plus by plus cz equal to d, and that means this 2, 3 and 4 is the direction ratio. So direction ratio of this normal to this plane is equal to 2, 3, 4. Okay? So apply the same process to find out the 2 square plus 3 square plus 4 square, and it is produced the 4 plus 9 plus 16, that means 29. And divide this 29, suppose we consider that this one is our equation 1, and the equation 1 is divided by, both sides is divided by this root 29. So 2 by root 29 x plus 3 by root 29 y plus 4 by root 29 z is equal to 12 by root 29. And we are already familiar with that. It is nothing but the direction cosine of this normal to the plane. That means it is our, this is our L. So this is our L, this is M, and this is the N. And this time this is the D, the value for the D. And our question is to find out the coordinates of the foot of the perpendicular drawn from the origins. And how to find out the coordinate of the foot of the perpendiculars? The formula is LD, MD and ND. So using this formula, putting the value in appropriate positions, that means the 2 root 9 into 12 root 29 comma 3 by root 29 dot, what is the value for the D? The 12 by root 29 4 by root 29 dot 12 by root 29. And from this we can easily get it is produced by 24 by 29 comma, it is produced at 36 by 29 36 by 29, and this time it is produced the 48 by 29. So this is the coordinates of the foot of the perpendicular to the origins. That's all for the today's lectures. Thank you everybody.